Applications of the integration in the real life, which is the projectile motions. So I will show the example of bullet shoot. I will present to you guys about the assignment that have been given, which is the application of integration in the real life application in the real life again. So this is we have to choose the main topics of projectile motions as our topic to explain this application of integration. So for the example is the bullet shoot, use the integration in the real life application. So this is the one of the question that we have been found, and it used the application of projectile motion with the integration. So it is said that the rock is thrown vertically upward at initial velocity of 40 meters second at a point of 5 meters above the ground level. Okay, so at this level, this is the ground level, and we assume that it's 5 meters. So the rock is thrown vertically upward. So the next is, it said that the velocity of the rock at the t second is given by the formula of v minus 10t meter per second. So from this, we can interpret it into the graph of distance against time. When the t is 0, the distance is at the 5 seconds, which is mean the height. And when it is thrown at the maximum height, the velocity is equal to 0. And from the equation this, we can make the graph of this, which is v against t. V is the y-intercept, which is c. So this is v, this is 40, and this is a negative graph because the negative sign. Okay, so when the t is equal to 0, the velocity is at the 40. The velocity at the 40 meter per second, and when t is equal to 4, this is v equal to 0, which means the maximum height. Okay, so for this four question, I will pass it to my friends to explain how to calculate it.
Okay, for the first question, it's stated here that find the expression for the height of the rock above the ground level at time t. So to do the expression of height, we know that v is equal to 40 minus 10t. So we have to integrate v to after we integrate v, we will get h equal to 40t minus 5t squared plus c. And for the second question, find the maximum height reached by the rock. Okay, when maximum height is when v is equal to 0. So v is equal to 40 minus 10t. We substitute 0 into the v, so we will get t equal to 4 seconds. So we substitute t into the h expression, we will get 85 meter. Okay, we need to calculate the distance travel in the third second. Distance travel is equals to height. So to find the distance travel in the third second, we can minus it into h at time 3 and minus h at time 2. So we integrate it using the time 3 and 2, and then we get 40t minus 5t squared. And the final answer, we will get 80 meter minus 65 meter, and the final answer is 15 meter. Next, when does the rock return to the ground? So when the rock return to the ground, the distance is equals to 0. So we know that h equals to 40t minus 5t squared plus 5, and then we can substitute h equals to 0, and then we can use calculator, and we get t plus 0.123 and t minus 8.123. So we get two answers, which is t equals to minus negative 0.123 and t equals to 8.123. Since t must be more than 0, so we get t equals to 8.123 when the rock return to the ground.
Hi, my name is Nur Ain Zulaika
Binti Zulkifli and my metric number is 192359.
Hi, my name is Wan Nazia Liana binti Manjusa and my metric number is 192032.
Hi, my name is Noran Zahra binti Zulkifli. My metric number 192225.
And thanks for watching!